Hi everybody, Mr. Peacock here. Today we are going to be talking about various segments and segment lengths in circles. So before we were talking about angles in circles, you might remember in the last video, this is pretty much the same thing, only we're talking about the lengths of the segments. So either inside or directly outside of the circle. Oh, I should put this on. Ooh, circles. Oh, there we go. This is geometry. All right, so let's talk about segment relationships in circles. This is going to look very similar, but I promise you it's different. We start with intersecting chords. Now, the rule about intersecting chords is this. If two chords intersect in the interior or inside of a circle, then the products of the chords of the segments are equal. Of the lengths of the segments of the chords are equal. So basically, if I said that this is A, this is, let's rewrite that, B. I'm going to make these purple, C, and D. Then the basic rule is this. A times B is going to equal C times D. So that's the idea. So the part of the chord times the other part of the chord is equal to the part of the other chord times the other part of, well, the other chord. Sounds really great, but we're going to practice this a couple times too. So let's try another one. Intersecting secants. So now we have two secants and they intersect, but notice that they have to intersect for this to work outside of the circle, or else they're not intersecting secants, they're intersecting chords. There's no rule about the outsides there. So if two secants intersect in the exterior or outside of a circle, then the product of the lengths of one secant segment and its external segment is equal to the product of the lengths of the other secant segment and its internal segment. So I'm going to once again go A, B, C, D. We are using these letters a lot today. So in this case, what this is saying is the external part of the segment times the whole. Now the whole segment is not B. It's going to be A plus B. So A times A plus B is going to equal C times C plus D. So that's the idea here. Now let's try this one, intersecting secant and tangent. So if a secant and tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external segment is equal to the tangent segment squared. Let's talk about why that is. So I'm going to say A, B, and C. So the secant part is exactly what we just saw. A times A plus B. But remember, what we're talking about whenever we do the secant is we are talking about the exterior times the whole. Well, let's think about that in terms of the tangent. The exterior, the part outside of the circle, is C. The whole is also C because it only intersects once. So that's the reason why that ends up working that way. Not just because I give you this little formula here on the bottom. It's because it's actually doing the same thing as the intersecting secants are. Which brings us to the most worthless of slides, intersecting tangents. So the measure of two tangent lines are equal. So think about it this way. If I say that this is A, this is C, then I would say something like, well, okay, A squared is equal to C squared, because that's what we did on the last one. We squared the tangent. But if we did that on both sides, we would be squaring them, square rooting them, which would just get us A equals C. This one isn't even in the book that I'm basing this off of. I just thought I wanted to show you that it continued to work by doing that. And this would literally be the whole lesson. Like, seriously, I could be saying like and subscribe and all of that. But I wanted to give us some practice. So let's go on. Here's our first practice problem. All right, so this is intersecting chords. So remember, the rule here is that the part of one chord times the other part is equal to the part of the other chord times its other part. So in this case, 6 times 6 is going to equal 4 times x. So let's see, that's 36 equals 4x. We divide by 4. This is like the only one where this is going to work out this well, by the way. And we end up getting that 9 is equal to x. Well, maybe not the only one, but it's close. All right, so there's our first one. Now let's try this one. So this is two intersecting secants. So remember, the rule is the exterior. So I'm going to start with the bottom one, 9 times the sum. You know what? I'm going to give myself more space. 9 times the sum of the entire length. So that is 9 plus 30 is going to be equal to 13, the exterior part, times the sum, which is 13 plus z. All right. So this ends up becoming 9 times 39. I am going to need a calculator. Is equal to, well, same thing for now. So I'm going to say 13 times 13 plus z. These can't change. Okay. So now that I know that, I'm going to pull up a calculator here and I'm going to try to do some math. All right, calculate 84, clearing it out, 13. Well, wait, I know 13 times 13. 13 times 13 is 169. So this will be 169 plus 13z. And over here, 9 times 39 gets us 351. So if I wanted to do this, the first thing I'd do is I'd subtract 169 from each side. And I know we all know what 351 minus 169 is off the top of our head, but I'm going to give you all a chance to think about it and realize that that number is 182. That's going to equal 13z, at which point we would divide by 13. And when we divide 182 by 13, we end up actually getting that z equals 14. So there we go. That's actually that answer. All right, let's try this one. Okay, this is a tangent and a secant. So on the secant side, we do 2 times 2 plus x. And on the tangent side, we're just going to say 5 squared. So this becomes 4 plus 2x. And that's going to be equal to 25. At that point, we subtract 4. 2x equals 21. Divide by 2. X is going to equal 10.5. Which makes sense. 2 times 12.5 is 25. All right, here's our next one. In this case, it's a little bit harder, but not a ton harder. In this case, we're doing the same thing. 8 times 8 plus 12 equals the tangent squared. So in this case, y is squared. So now we just have to do 8 times 20, and that is 160. And that equals y squared, at which point we square root each side. So I square root 160. I could simplify this a lot quicker, but I'm just going to go 2 times 80, which is 2, times 40, which is 2, times 20, which is 2, times 10, which is 2, times 5. So let's see. Pair, pair, and we're left with 10. So that becomes 2 times 2 square roots of 10, or 4 square roots of 10. Now let's try this one. This one's a little bit crazier. So in this case, I'm going to need to find x and then use x to find y. So the first thing I'm going to do is find x, which means all of this I'm ignoring. But I can't erase that because I'll need it later. So 4 times x is equal to 10 times 3.2. 10 times 3.2 is 32. So 32 equals 4x. I divide by 4, and that gets us that x is equal to 8. So x is 8. Now that I know that, we have to keep going though. I now need to find y. And so I know that y squared is equal to, in this case, let's see, that would be 6 times 6 plus 8 plus 4. Okay, so that's actually 6 times 18. So y squared equals 6 times 18. So let's see. 6 times 18 is going to be, well, that's 12 less than 20. I mean, less than 6 times 20. So that's going to be 108. So y squared equals 108. I really kind of hoped this question would lead me to a nice perfect square, but no. Square root of 108. 2 times 54 times 2 times 27. 3 times 9, and 9 is of course 3 times 3. So we have a pair of 3s, a pair of 2s, and all that is left over is a 3. So that becomes 2 times 3 square roots of 3. So y equals 6 square roots of 3. All right, and now we're doing a challenge one. 10 squared equals y times y plus 6. So that means 100 equals y squared plus 6y. So let's see, I'm going to need to subtract 100 from each side. So 0 equals y squared plus 6y minus 100. Okay, so this is a nice little factoring problem. Okay, so can I factor numbers that multiply by 100 and have a difference of 6? Let's see if there's one that's good. So let's see, there's 1 times 100. There's 2 times 50. There's 4 times 25. There's 5 times 20. There's 10 times 10. Okay, none of these have a difference of 6, meaning we are not doing that. So I'm going to put this one in Desmos because Desmos is way easier for this. And I'm going to type it as x squared plus 6x minus 100. And I actually get technically two answers. I get negative 13.44 Or I get positive 7.44. So the question becomes, which of these is the right answer? And for that, we have to just ask ourselves, can distance be negative? Nope. Then that means it's not this, meaning it is definitely 7.44. And there we go. Thank you all very much. If you wouldn't mind, please like and subscribe. Comment for the algorithm, all that type of stuff. Like it. Don't dislike. Don't do it. Please. All right. Anyway, like and subscribe. Woo! Bye, everybody.